Hello and welcome. In this tutorial, we will implement Anaglyph 3D rendering in Max. This tutorial consists of 3 parts. The first one is setting up a simple particle system. In the second one, we will implement the stereoscopic rendering. And in the third one, we will do some tweaking and some additions to make it look a bit more convincing. Before we start, maybe we should do a little introduction to Anaglyph 3D. So what is it and how does it work? So I recently saw an art installation that used these red and blue 3D glasses. So I ordered some of them, made some experiments, and one thing led to another. And yeah, I guess now you're watching this tutorial. So in order for this to work, you need to have these blue and red or red and blue 3D glasses. They're pretty cheap, you can order them online, but in order for this effect to work, you need them. So the effect we're implementing is called Anaglyph 3D, and it's a form of stereoscopic 3D. So if you think about it, why does the world or why do your surroundings even look 3D to you? It's because each eye gets among others, but each eye gets a different image. So this technique will take advantage of that. So we will have a resulting image that contains 2 differently color filtered images, and then the glasses will then filter it again. So each eye only gets one separate image. Yeah, when using the glasses, each eye only sees the image it is supposed to see. So the left eye gets the red image due to the red filter, and the right eye gets the blue image due to the blue filter. And so there's no need for a head-mounted display. You can just project this on the big screen and then use your red and blue 3D glasses, and it should pretty much work. Okay, I guess we can start then with the first part, which is implementing a particle system. So to do this, I will use a BFG as an input. So this is an object that outputs many different noise functions just as a matrix. So in order to see something, we first need to give it an offset, then also bang it on every frame. And here we need to specify the number of planes. So I want it to be 3D. So I'm going to use 3 planes, float 32, 100 by 2 by 2. And as a basis, I will use noise simplex. And I will set the scale to something like, 15. Now, in order for this object to work, we need to start the JIT world. And now we can see the output here. Yeah, I'm using 2 and 2 because that's the smallest that you need in order for this to work. But then I will kind of clamp or downsample this again. So I will use a matrix, 3 planes, float 32. And let's say this is 200 by 1. Then we can say interp 1. So here we have 100, here we have 200, but the colors will get interpolated. So now we only have 1 plane, or we only have 1 cell on the y-axis. And the colors that are coming out here, I think, or the numbers, yeah, they will be above 1 and below 0, so we can use jit.normalize to get it in the range of 0 to 1. So that's the input for our particle system that we need. I will delete this, put this down here. Now, I'll put this up here. I want to use a particle system that is made up of cubes. So I will create a jit.gl grid shape. The shape is a cube. The dimensions, I will use 9 by 9. I think that's the smallest you can use in order for the cube to be accurately rendered. And then it's also important to say automatic 0, because we don't just want to render this on the screen. We want to control it by a jit.gl.multiple. So in order to do this, we create this jit.gl.multiple. Then we need to tell it how many inlets we're using. So 3 for our free GL parameters. So we need to tell the cube, or the cubes, their scale, their position, and their rotation, rotate X, Y, Z. Yeah. No. Something is still missing. So this input will control the scale for all of our 200 cubes. So we have 200 cells here, so we will get 200 cubes. And for each of the cubes, we can say what kind of scale we want, what position they should have, and what rotation we want to have. And to do this, I will use a jit.gen. Let's call this one, so give it a title, scale, pos, rotation. And now I will use this noise function that we're getting out of here to create a scale, a position, and a rotation for our cubes. So to do this, we need 3 outputs. The first one is scale, position, and rotation. So for the scale, we can just use something like 0.1. Then for the position, we can just say, so this number between 0 and 1, we want to scale this on a range of -2 to 2. And for the rotation, we could also just take the input and scale it like, I don't know, X rotation 1. So this is in degrees, not in radians. So I don't know, something like 180, 720, and 900. We can plug this in here. And this should theoretically already be working. Okay, yeah. I made a mistake here. I called this cape. Now we have cubes. Okay, first thing I want to change is the speed of the jitter.time, because this is way too fast. So let's do something like 0.15. Also, the cubes are way too big. So I think I have to scale the position by their size and do something like dividing this whole thing by 0.1. Okay, this looks much better now. And I guess we could also change the size so they don't all have the same size. So we could do something like multiplying this here. So the scale by yeah. Okay, not input one directly. We could just use the x-axis. So, because some of them get like squished, so we're only taking one axis. But now the scale is very much dependent on the position because we're using the same input. So maybe we can do something like RGB to HSL just to change what's coming in here and to mix it up a little. And yeah, because now it's not that obvious that we're using the same input to control the three of them. So this is almost done. The only thing that's missing is, yeah, maybe add a material to make it look a bit more realistic. jit.gl material. Look at that. Okay, so that's it for the first part. We have a particle system made up of cubes. I also tried this with a simpler particle system, like just using a jit.gl mesh and then just have points floating around, but it looks way better and the Anaglyph 3D effect is way more convincing when using cubes and also when using a material. So it's not just monochrome point that's floating around, but you can actually see shadows and different colors and shading. Yeah, let's start with the second part, the stereoscopic rendering. So as we discussed earlier, for this effect we need two cameras, one for each eye, and then each camera is kind of mimicking one eye, so they are at different positions and like they have exactly the distance between two eyes in between them, but they're looking at the same thing. And that's how we get two different images, one for each eye. So to do this, I think I will, create two node objects, so jit.gl.node. So this is like a new rendering context. So now we're rendering this whole thing to our jit.world, but we can also have like a sub-rendering context kind of, so we can take this whole thing and render it to this node or use many different node objects and render it to different node objects within one scene. So I will give this one a name, so left, so this represents the left eye. The dimension will be like full HD. And what else do I need? Maybe a depth 0 couldn't hurt, and also let's say capture 1 because we want to see what's coming out of here. So at the moment, nothing is coming out of here because we have to tell, I think, this object where to render its contents. So say add draw to, and then we can say left. And now you can see it's getting rendered here. Then we also need a camera. So jit.gl camera. This one will look at the center. We'll say log look, so this doesn't change. And we also have to tell it where to draw its content. So we'll also draw this to the left. Then we can just copy this whole thing, but now we get an error because this node with the name left already exists. So we call this one right, representing the right eye, and this camera also draws to the right. So we still can't see anything here because we also have to tell this object to render its content to the right. Okay, so both of these cameras have the same position now. So we need to change the position for the cameras and maybe also the lens angle. So to change the position, we can use this pack object, position 0, 0, 0. So the y-axis or the y position for the cameras should stay the same, and the z-axis should also be the same for both of the cameras, but what we want to change is the x-axis. So copy this here, doing this in parallel. So we can do something like trigger float, multiply this by -1. So whatever y position we're setting, the left eye gets shifted to the left and the right eye, oh, this is wrong, will get shifted to the right. Then we can change the x-axis here, use something rather small because this is in, I think 1 represents 1 meter, so we have to do something like, I don't know, 0.005 to get the distance between both eyes. So this one is going to be Did we even get something in here? Does this work? Okay. Okay. So this will be shifted 0.005 to the left, and this one will be shifted 0.005 to the right. Okay, we could also change the Z position for both of them to move closer or further away. So I'll also use a float. I don't know, let's use something like 2. And then, yeah, what also might be relevant is the lens angle for both cameras. And the position we're looking at. Where is it? Look at, okay. So now we're looking at position 0. Now we're looking at position 0, 0, -5. Okay, so moving on to the color separation. So we need a red image for the left eye and the blue image for the right eye. So we can just do something like this using a jit.gl pix. I will call this one at title red, and here we only want the red channel, so we can multiply the red channel with 1 and the other channels just with 0. And now look at that, we have a red image. Then here we're kind of doing the opposite, so we're multiplying red with 0 and then green and blue with 1. And then we have this image here. And now the only thing we have to do is to combine both of these images. So yeah, again using jit.gl pix. Maybe I'll also give this one a title so we can add them. Yeah, I guess I still want to monitor what's coming out here. So and now to see the final image, we can just plug this one in here. So if I stop this for a second, you can see that, yeah, depending on where the cube is positioned within the scene, you get more or less of this red and bluish border on the side. That's essentially how this effect works. So there will be some areas where there is like a complete overlap, so everything that has like one color is the same for both eyes or for both filtered images, and everything where you can see this red or blue border, it's like this is the difference between the two images, and this will then result in the 3D effect. I guess that's it for the second part. So we set up the stereoscopic rendering. We can now move on to the third part, which is tweaking and additions. So what I would like to do is first a little color change, because depending on what kind of glasses you have, this might not be the right shade of red. So this is something you have to test out yourself. Then I want to create a vignette, because here on the edges of the screen, the illusion kind of breaks because they kind of appear out of nowhere. So I want to create like a smooth vignette. And then we can also create a depth of field effect, so that, yeah, cubes that are closer to us get blurrier than cubes that are farther away. So this also helps with the illusion. So first I will start with the color change. Something else I noticed is that, at least for me, this effect works better if the background color is white instead of black. So I will change this for now. Then, yeah, we can also change the colors in here depending on what glasses you're using. So I tweaked this a bit beforehand, and for me, like a 0.8 on a red channel looks better, and on the blue channel, it's something like 0 for red, 0.85 for green, and 1 for blue. But yeah, in order to tweak this, you have to use your own glasses to see what works best. Because in theory, if you're looking at this picture with the blue lens, you should just see black, and if you're looking at this picture with your red lens, you should just see black as well, or it should be very dark. So this is how I calibrated it, like holding the lens in front of the screen and then just tweaking the color parameters. Okay, then moving on to the vignette. So to create this vignette, I would use a jit.gl pix. Let's call this vignette. And to do this, I will just first I will create a circle. So to create a circle, we can use side normalized coordinates. So they're reaching from, so we have on both axes, like on X and Y, or in this case on red and green, we have 0 in the middle, -1 up here. This is -1, 1. This is 1, -1, and this is 1, 1. So this is what that means. And if we use the length operator, we get the length of each vector here. So in the middle, it should be 0, 0. And here it should get closer to 1. But it's actually not 1, it's the square root of 2. So good thing we have this square root of 2 variable in here, so we can just divide it by the square root of 2. And now on these edges we have 1, and here we have exactly 0. Then I want to invert this because I want I want black on the outside and white on the inside. So it looks something like this. And you can see if I remove this square root of 1, there is much more emphasis on the black out here. Okay. Then we could also use like a power function. So now we are getting values between 0 and 1. So if we apply this exponential here, you can see that we can scale this a bit. So do something like this to make it brighter, or something like this to make it a bit darker. Yeah. And now the only thing we have to do is multiply this by input 1. And then the dark gets applied on the edges. And here we have maximum brightness in the middle. So then what we could also do is change the lens angle. So, I mean, you'd have to test and tweak this with your own setup. For me, I found that 50 degrees looks pretty good. And also here for the distance between the eyes. I mean, this also depends on your individual setup, and of course also on your like physiological setup, like how far your eyes are actually apart. So for me, this 0.075 works really well, but these are just values you can tweak. Okay, so we did the color change, we did the vignette. Now we can do depth of field. So to do this, first I will make a bit more space down here. Then we can use a pass effect. So this jit.gl pass will just take what is rendered here and apply like this. I mean, depending on what you're doing, now we're applying a depth of field effect, but there are also like blurring, bloom effects. Yeah. So this will be applied to whatever is rendered in here. So first we'll tell it what effect we want, and I think it's depth of field IQ. Is that right? Okay, yeah, it's already blurry, so I guess it's working. Then I think it's called lens focal distance. And I like to set this to like again, this is something you can tweak, and it is probably highly dependent on your setup, but for me it works very well to use like the same number that I use here for the Z axis. So I will set this to 2. Then we can say lens focal length. Let's set this to 1. And then we can say lens max blur and set this to 2. Now this needs to be connected here. And we can put this here, and of course we need the same thing here. So now it should be obvious that some parts of the image, like the cubes that are nearer to the camera, get blurred, and whatever is further away doesn't. Yeah, so again, this is really depending on your personal setup. Like you would have to tweak this yourself and see what kind of works best for you. And yeah, when looking at this, the bigger the screen, so I found usually the bigger the screen, the better. So watching it on a phone doesn't work as well as watching it like with a big projector. It also depends on your distance from the screen. So this is essentially what I wanted to show you. Get yourself a pair of Anaglyph 3D glasses and yeah, just experiment with them. I hope you found this useful. Thanks for watching.